A potentiometer is essentially a voltage divider that is used for measuring voltage potential, and it uses the principle of the potential divider. It has a driver cell, as we can see, and this driver cell is connected to a slide wire in a circuit we shall call the primary circuit. Now, this lower portion of the circuit is what we are calling the secondary circuit, and the secondary circuit is this lower bit, and it essentially always has the galvanometer plus something else connected here. Now that something else can either be a cell or a resistor. Now, this driver cell, when it provides current, it's supposed to provide a constant amount of current that is supposed to be going through that potentiometer. Now, a potentiometer, how it works is simple. In case we want to find the EMF of this cell and we do not know the EMF, we are going to get this primary circuit, then we shall connect, like you're seeing in green, we shall connect this EMF to the secondary circuit with a galvanometer in series with it. Then what happens is that we are going to get this portion, or this sliding jockey, and we are going to slide this wire along the slide wire. We slide this portion along the slide wire. Now, as we are sliding this wire along this length, this galvanometer will be deflecting. Now, we are supposed to stop at a point whereby the galvanometer shows no deflection. When the galvanometer shows no deflection, it means no current is flowing through. And it means that at that point, there is no current flowing through the secondary circuit. When there is no current flowing through the secondary circuit, it means that we have achieved what we call the balance point. And if we have achieved the balance point, then it means that we have what we call a balance length. So when we have a balance point and a balance length, the balance point being the point where the galvanometer shows no deflection, then we can go ahead and find the EMF of this cell using this potentiometer circuit. So now, how do we find the EMF of this circuit when we have achieved the balance point? Now, that is where the principle of the potential divider comes in. Now, in our previous explanation, we said that we derived the principle of the potential divider and discovered that the potential difference across a section of the wire, like for example the portion of the wire AB, in which case the point B being the balance point. So the potential difference across this portion of the wire is always directly proportional to the length of that wire, and that is the principle of the potential divider, and that's the principle we are going to use here. So when this balance point is achieved, the potential difference again between A and B, the balance point, this being the balance length, is going to be equal to the potential difference across whatever is in the secondary circuit. If you're having a pair of resistors, if you're having the EMF, or cells, the potential difference across AB at balance point is going to be equal to the potential difference across what is in the secondary circuit. Now, in this case, since we are interested in finding the EMF of this cell E, it means that when we achieve balance point, the potential difference across that portion of the wire AB is going to be equal to the potential difference across that cell. In this case, which we are saying that VAB is going to be equal to E. But we know that the potential difference across AB, which is a portion of this whole wire, is going to be equal to, now from the principle of the potential divider, we said that the potential difference across a portion of the wire is directly proportional to the length of that wire. So if this length, the length of this wire, of the balance length, if we call this balance length to be our value of X, and the length of this whole wire from here to right to there is L. So it would mean that the PD across AB over the PD across AC is going to be equal to the length AB over the length AC. And this is what we did here, that the PD across AB divided by the PD across AC is going to be equal to the length X over L. over the original length. So we derived this. We got this from our previous video, the principle of the potential divider. So we go ahead and say, so meaning that if this is how we can, the other way we can express the potential difference across AB, it means that our EMF E is going to be equal to the PD across AB, which is expressed in terms of this, which is that right there. So we can go ahead and find the PD across E. So this V, we have V over L right there. So we have the potential difference across SC over L, which we rearranged here as VSC over L times this X. Now this VSC, this is the potential difference across the entire wire. Divide that by the length of the entire wire. Gives us what we call the PD per unit length of the wire. Now, since we know that the potential difference across a wire is directly proportional to its length, which simply means that the longer the wire, the longer the potential difference, and the shorter the wire, the less the potential difference. It means that this potential difference and the length of the wire have a linear relationship. So if we divide the potential difference of the whole wire by its length, it means we are able to get a constant called the PD per unit length. So it means that here, since we are saying that when we obtain balance point, that the potential difference across the balance length is going to be equal to the potential difference across whatever we have here in the secondary circuit. For us to easily get this potential difference, we simply have to get the balance length, and then we multiply that balance length, which is in this case X, we multiply it by the PD per unit length. Now the PD per unit length is what is being represented by VSC over L, which we are calling a constant K. So for us to get the EMF E is we get the PD per unit length, which is the value of K, times the balance length we've gotten. Now, the potentiometers can have a slide wire of any length. It can be 1 meter, it can be more than 1 meter, depending on the needs. So what we need to find is the potential difference across the entire length of the wire. Divide that by the entire length of the wire to get the value of K. This value of K is what we are calling the PD per unit length of the wire, and the process of obtaining this value of K is what we call standardizing the potentiometer, or the process of standardization of the potentiometer is in essence the process whereby we seek to find the PD per unit length, because once we know the PD per unit length of any slide wire, then it makes work easy for us to be able to get the potential difference across whatever components that are in the circuit, whatever components that are in the secondary circuit.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.